The third and final gas law is named after Joseph Gay Lussac. It's called Gay Lussac's law, and it relates the pressure and the temperature of a gas. So Gay Lussac's law can be written as the pressure is equal to a constant times the temperature, or we can write it as P1 on T1 is equal to P2 on T2. Let's have a look at an example of a problem that we can solve with Gay Lussac's law.
The pressure inside a cylinder of gas at 20 degrees C is 1,300 kilopascals. If the gas bottle is stored next to a barbecue, its temperature can increase to 70 degrees C. What would be the pressure inside the cylinder now? And why is this not a good idea? So to solve this one, we use Gay Lussac's law. We have P1 on T1 is equal to P2 on T2. What we need to find is the new pressure, so we can write this as P2 is equal to P1 times T2 on T1. Now it's important to remember that the temperatures here need to be in kelvins. So our pressure is 1,300 kilopascals, and this is times the new temperature, which is 70 degrees C, which is 70 plus 273 kelvins, over the initial temperature, which was 20 degrees C, which is 20 plus 273 kelvins. So solving this on the calculator, we get 1,520 kilopascals. So you can see the pressure has gone up a fair amount. So why is this not a good idea? It's not a good idea to store gas bottles in hot places because the pressure inside can increase, and when the pressure increases it means that there's more force on the walls of the container. So the gas bottles are only rated up to a certain pressure. Beyond that pressure the gas bottle can explode, which can be very dangerous. So this is what happens if you place a can of Coke inside a car on a hot day. The pressure inside the can decreases dramatically, and if the temperature gets hot enough, this can cause the Coke can to explode and spray Coke all over your car.
We'll come back and have a look at the demonstration of Gay Lussac's law in a minute. But first of all, we can place all these equations together into something called the ideal gas law. The ideal gas law can be written as PV is equal to nRT. In this equation, P is the pressure in pascals, V is the volume in meters cubed, N is the number of moles, R is the gas constant, which is equal to 8.314 joules per mole per Kelvin, and T is the temperature measured in kelvins. Now let's have a look at the demonstration. The demonstration is going to have a look at PV equals nRT, and then we'll be looking at Gay Lussac's law. What I have here is a glass flask, an egg, some paper and some matches. In a minute what I'm going to do is light the paper, place it in the flask, wait a minute and then put the egg on top. Now I want you to think about what's going to happen to the egg when I place it on top after we've lit a fire in the flask.